Fluid lines and fittings. For the fittings, the rigid tubing is measured in 1/16 of an inch based on the outside diameter of your tube. Flexible lines are measured in 1/16 of an inch based on the inside diameter of the hose. If you have an AN 818 nut, which fits your flare tubing, the dash number that comes after the 818 represents 1/16 of an inch diameter that the nut will fit. For example, an AN 818-4 would fit a 4/16 or 1/4 inch tube. We use AN 818 nuts and a sleeve, which helps to eliminate the possibility of reducing the thickness of the flare by the wiping or ironing action when the nut is tightened or torqued. With the two-piece fitting, there's no relative motion between the fitting and the flare when the nut is being tightened. Your MS flareless fittings are attached to the end of the metal tube by presetting the fitting onto the tube. Presetting, using enough pressure on the fitting to deform the ferrule, will cause it to cut into the outside of the tube so that it won't move. Presetting is done by lubricating the threads of the presetting tool and the nut with hydraulic fluid, then assembling the nut and the ferrule onto the tube, putting it into a presetting tool, and then tightening the nut by hand until resistance is felt. Then turn it with a wrench from 1 to 1 1/4 turns. So no specific torque, just once you start to feel resistance, turn with the wrench 1 to 1 1/4 turns. When installing the fitting in an aircraft hydraulic system, tighten the nut by hand until resistance is felt, then turn it 1/6 to 1/3 of a turn, 1 hex to 2 hexes with a wrench. So once you start to feel resistance, turn it about 1 hex of that nut, up to 2. AN flare fittings have a shoulder between the end of the threads and the flare cone. And some people are like, what does this mean? So there's our flare. Now the AC fittings would go straight into threads, but our AN has a little blank spot before it goes into the threaded portion. And that would be your shoulder, that little blank spot. So that's one quick way to identify between an AN and an AC fitting, is looking for that shoulder. Again, the AC fittings, the threads go all the way to the cone. It doesn't have that blank spot. AN fittings are dyed blue or black, and AC fittings are gray or yellow. AN because it's after World War II and what we mostly use nowadays. Blue indicates that the material is aluminum. Black tells you that it is steel. AN and AC fittings are not interchangeable. They have different flares. AN is 37 degrees and AC I believe is 35 degrees. The main differences are shoulder, thread pitch, and sleeve length. So I always tell people, think of baseball when they're studying for their tests. The three main differences: shoulder, pitch, and sleeve. So if you think of a pitcher throwing the ball, he's moving his shoulder in order to pitch, and the length of his sleeve. That's one way to remember. A hand-operated wheel-type tube cutter is the best tool to use when cutting aluminum tubing or any other moderately soft metal or material. If you use it on steel, you will damage the wheel, the cutting wheel, so do not use the roller cutters on steel. Double flare has some advantages over single flares. It's smoother, more concentric. The extra metal makes it more resistant to the shearing effect when torqued. But all in all, we use single flare most often on our aircraft. There should be no tension in your lines, so the flare in both ends of the tube should rest squarely onto the flare cone of the fittings. It should not have to be pulled into place with your nut. And also, when you remove your nut, you should not have a spring action with your tubing. It should rest right there at the cone. The minimum radius for steel is greater than for aluminum, and that's talking about the bend radius. Aluminum is a softer metal, so it can make tighter turns. Steel, being a harder metal, would be brittle and more susceptible to breaking with a tight turn. So it has a greater minimum bend radius. Flexible hose is inner diameter, and the outer diameter of a rigid hose is the same size, have equivalent flow characteristics. So when you're comparing the two, remember, hoses are measured inside diameter, tubes are outside diameter, and as long as they have the same size, say 1/2 inch, they have the equivalent flow characteristics. Tubing rigid lines, you have high strength and abrasion resistant necessary. Tubing, it will be made of corrosion resistant steel, annealed or quarter hard. It's used in high pressure hydraulic and pneumatic systems where that high strength and abrasion is needed. Aluminum doesn't hold up very well to abrasions. It'll start wearing down relatively quickly, so we use that corrosion resistant steel. Plain clamps, where there's no vibration, most areas you're going to use it, you're going to have some vibration, so you're going to use cushioned clamps. And for electrical bonding, you will need to remove paint or the anodized surface from the metal so that you have metal to metal contact. So if you have a flammable fluid in the line, you're going to need that bonded clamp. All tubing must have at least one bend. This is to allow for shifting of the line as it is pressurized. It's kind of like a stress reliever for it. So all lines must have at least one bend. Creating flares. A proper order you should use to make your single flare on a piece of tubing. You, number 1, slip the fitting, nut, and sleeve onto the tube. Make sure that you're doing it in the correct direction. So the cone part of your sleeve will be pointed toward the end you're going to flare, and then your nut, the threads, will be pointed toward the end you're going to flare. A lot of people forget to do that step. They just go straight into flaring, and then they're like, oh, where's my hardware? So that's your number 1 thing, is put your hardware on the correct way. 2, place the tube in the proper sized hole in the flaring block. 3, center the plunger or flaring pin over the tube. 4, project the tube end slightly from the top of the flaring tool. Depending on the tool, most of them recommend about the thickness of a dime to about 1/4. Tighten the clamp bar securely to prevent slippage so that the tube does not slip out of the flaring block. And then 6, strike the plunger with several light blows with a lightweight hammer or mallet, and turn the plunger 1/2 turn after each blow. Those would be your steps. Creating your flex lines. make sure to allow 5 to 8% slack between fittings. Rigid lines, you always want to cut like 10% just in case you forget to put your hardware on and you need to cut a little bit off to put the hardware back on. Just a side note. But for your flex lines, make sure to allow for 5 to 8% slack between your fittings. This allows for expansion in diameter and contraction in length under pressure. If any of you have turned on the water on your garden hose and you've had the end capped off, you would have noticed that the hose expanded in cross-sectional area, which is diameter, and it would have contracted a little bit in length, which is why we're leaving a little bit of slack in our flex lines. The term cold flow describes deep permanent impressions left in a natural or synthetic rubber hose by the pressure of hose clamps or supports. If you've ever taken off the clamps on your coolant system in your car, leading up to your radiator, there's a flexible line, and if you undo that little clamp, you'll see impressions left by the clamp, and that is cold flow. Compatible materials for fluids, phosphate ester based, is butyl and Teflon. I say Old Lady Esther Skydraw was a brutal old lady that cooked with Teflon. Keeps it straight in my head so I remember. In your petroleum or mineral based is Buna-N and neoprene. 5606 is an example of this, so I say Secret Agent 5606 wanted to be a red ninja because his color is red, and it's Buna-N and neoprene, the two N's, just like ninja has two N's. Just a way to keep it straight. Teflon hose actually develops a set over time or is manufactured with a preset shape. Support is necessary to prevent straightening inadvertently if you take it off, and you want to make sure if you do take it off that you put it back on the same way it came off because of that preset, so you don't start cracking the Teflon. Another cool thing about Teflon is it does have a compatibility with nearly every fluid. It has a wide operating range of temperatures, and a long service and shelf life. So Teflon is quite amazing. Damage! If a piece of high pressure hydraulic tubing is damaged in a localized area, the damage can be cut out and a new piece of tubing cut to replace the damaged section. Swedge type splice fittings are slipped over each end of the tubing, and the fittings are swedged to the tube ends. Remember, scratches or nicks are allowed in a piece of aluminum, provided they are no deeper than 10% of wall thickness of the tube, and it's not in the heel. There should be no damage in the heel of a bend. A lot of people go, what's the heel of the bend? The heel is the curved part, if you think about it kind of like a foot. That is the heel of your bend. No damage is allowed there because pressure is hitting that heel and making a turn. So it's under a little bit of stress. You don't want to stress it out more with some damage. Some other people want to know about wall thickness. When you look at the end of the tube, ta-da, kind of looks like a donut. Remember, it's measured the outside diameter and 1/16 of an inch. And then the wall thickness here is from the inside to the outside. So if I wanted to find the inside diameter of my tube, I could take the outside diameter minus 2 wall thicknesses and find my inside diameter. But that's what they mean by wall thickness. So you can measure it, and as long as it's not 10%, your scratch isn't more than 10% of your wall thickness, you're okay. And as long as it's not in the heel of the bend. Scratches and nicks should be burnished out of the tube to prevent stress concentration, so kind of smooth it out, burnish it. That way there's no stress concentration point where a crack could form. Dents can be 20% of the outside diameter. Also remember you can put a bullet or a ball through and push that dent back out so that it doesn't interrupt the flow. So scratches, 10% wall thickness, dents, 20% outside diameter. During bending, it is not satisfactory if its small diameter is less than 75% of the outside diameter of the straight tubing. So you're allowed to flatten in a bend not more than 25% of the outside diameter of the tube. So when you bend, sometimes there's a little bit of a flattening action that happens. You just have to measure and make sure you're within limits, not more than 25%. Or it's not smushed more than 75. Markings. The fluid carried in fluid lines in an aircraft are identified by a series of color-coded bands around your line. So you have blue and yellow is a color code for hydraulic lines. There will also be a white band with black geometric symbols, and this helps benefit colorblind people, and it has words. So you might see diamonds, triangles, and it will say hydraulic or oil, bleed air. So all those lines will have a color code for the people that can see color, so it's easily recognizable. And then for our colorblind friends, we have symbols and words. If you see FDAN, it means it is physically dangerous, whatever liquid is in that fluid line. If you see FLAM, it means it is flammable. Skydrol or phosphate ester-based fluids, flex lines are green and they have white ley lines. Remember, ley lines contain information such as your manufacturer, manufacturing date, size, all that information will be on there. And do not twist the ley line when you install. Usually when I'm installing fluid lines, I want to make sure that I can see that ley line during an inspection to make sure it didn't get twisted. And when I go to torque, I watch to make sure that it doesn't accidentally start twisting. So do not twist against the ley line, and to make it easier for yourself and your fellow mechanics when you go to do an inspection, make sure that you can see that ley line through an inspection panel. It's just courteous. Other than that, that's all for flex lines and rigid lines. That's our fluid lines and fittings. Have a wonderful day.